Okay, so in this recording, I am looking at factoring a trinomial where the lead coefficient is not a 1. And when I say lead coefficient, I mean up here in the front, this is our lead term because it's got a degree of 2, while this one has a degree of 1 and this one has a degree of 0. So because there is a 12 there in the front, it may not be as simple of a factoring as these. Both of these have coefficients of 1 at the very front. So what do? It's known as the AC method. Again, in that last recording previous to this, I think this would be a good idea. If you haven't seen this one, watch how to factor trinomials, and also watch this one where it's factoring by grouping, where you have 4 terms. So here's what we're going to do. Keep in mind that when we've got a polynomial where it's a degree 2, a degree 1, and a constant, we usually call this our A, plus 5 would be our B, and negative 3 would be our C. And so the AC method, there you see it, AC, means to get rolling, take your A and your C and multiply them together. Take your A, multiply it times your C. Now, in this example, that would mean taking your 12 and multiplying it times your negative 3. See what you get. That'd be negative 36. Now, what we're going to do is we're going to look at what 2 numbers would multiply to give us specifically the sign negative 36. And that when you add them up would give you the value for this B, which is a positive 5. And be real specific about the signs. Again, take some time to think about, like, what are all the things besides 1 times 36 that would give you, that multiply to give you 36. This would be a 2 times an 18, which are 16 units apart from each other. Then there's also a 3 times 12, which those are 9 units apart from each other. There's also 4 times 9, and then there's also 6 times 6. But notice that 4 and 9, if you think about how far away they are from each other, they're 1, 2, 3, 4, 5 units away from each other, and that has something to do with this here. So that those two have the highest potential for being the 2 numbers that we're looking for. So I'm going to put them both here, 4 and 9. But now somebody's got to be a negative. And is it going to be the 4 or is it going to be the 9? Now, if it's the 9, that's not going to work out down below because that's going to leave us negative 5. So that means it does need to be that the 4 is the negative because this works. Negative 4 times 9 is negative 36. And when you add negative 4 and 9, you're going to get a positive 5. And so now here's what's different about what we did earlier. Earlier it was like we were done. Okay, we were done. But in this case, what's going to happen with these two is these are going to become a split. It's going to be the way that we split this middle term into 2 pieces. So we're going to bring down the 12y squared. We're going to bring down the minus 3 because they're still there. But we're going to take the 5y. We're going to split it into minus 4y plus 9y. And anytime one of them is negative and one of them is positive, it's better to have, I think, a little easier to work with when the negative belongs to the first group and the positive one is the leader for the second group. And now from here, it's factor by grouping because we only had 3 terms to begin with, but now we've got 4 terms. And now we're looking for, again, if you haven't watched the recording on factor by grouping, it's now we've got group 1. We're going to factor out GCF. In this case, we're going to be able to divide both of them by 4. That's going to be a common factor. And then we also have a y. This one's got a y times a y. So they both also have a y in common. So identify the GCF. Let's go ahead and take that out. It's going to be a 4y. And now think of it as like division. 12 divided by 4. That leaves 3. And then if we take a y out from the first term, it leaves a y. Now, since we're taking all of y, 4y, out of the second term, what's going to stay behind as a kind of in position here is a minus 1. Again, just imagine yourself. We multiply these two, that's going to give us 12y squared. And if we multiply this times this, that's going to give us 4y, a negative 4y. So that's one thing to be careful, is that if ever you take out all of this, think of it as you're leaving a 1 behind. Now let's see what happens over here. It's a 9 and a -3, which means we can do divide 3. That's our GCF. So we take out a 3 from each of these, is going to leave us 3y. Again, if this is, think of it as divide by 3, that'll be a -1. And so this matches, and this matches. This is good. Again, if you want to use just these really big parentheses, or sometimes I'll use like a big square bracket. And so that binomial that I just put the little wavies underneath, that's what's going to come out as your common binomial. And then what's going to remain behind is going to be the 4y plus the 3. Again, you're imagining this coming out. You're imagining this coming out. And so the 4y plus 3 is all that's going to remain behind. And if you wanted to, you could check this with the box method. Like again, I'll at least get you started, with the box method. If you were to multiply the 3y minus 1 and the 4y plus 3, you should be able to check that it's going to get you back to that product. 12y squared, 6y minus 5. Yeah, it's going to work. It's going to work. I'm just kind of mentally just doing it in my head, but that should be good. That should be the factorization for it. Now, the thing that I'm not doing in this video is solving, where if we're going to do something like the zero product property and had it set equal to 0, then we could solve for what y is. But right now I'm just focusing on just factoring. Let's do another one. This here is another opportunity, because this is not a 1, where we could use the AC method. So again, this is our A, -19 is our B, and C is our plus 10. So it's called the AC method because we're going to multiply A times C, so 6 times 10. Again, I'll write it over here. A times C means, let's take the 6 times the 10. This gives us a positive 60. And so now we're looking for what two numbers that when we multiply them will give us a positive 60. And be real specific about the signs. And we want those same two numbers that when we add them give us -19. Again, make a list of all the numbers that multiply to give you 60. That would be 1 times 60, 2 times 30, 3 times 10. And keep going until you see something that's going to maybe be a distance of 19 away from each other. I'm still not seeing it. 4 times 15, and actually there it is, right? Actually these look like they've got some potential, because not because of their distance, but because we know that 4 and 15 do add to make 19. And so when you notice little things like this, then start experimenting with them. So let's put 4 and 15 here. And now what would make this work so that we multiply, we get positive 60, but when we add, make -19. Now in this case, if one of them is negative and the other is positive, it's not going to work out. But if they're both negative, that will give us positive, and if they're both negative, that will give us -19 when we add. So what we're going to do with these two, once we found them, is we're going to come here and we're going to split this up into -19r and -15. Excuse me, not -19. I'm going to put -4, right? Because we said -4 and -15 are the numbers we're looking for. This is still -19r. It's just now it's split into two little pieces. Everything else comes down, 6r squared and the plus 10. Now this gives us our 4 terms, so we can make our groups. But when we make our groups, this one's perfectly fine. But whenever there's a negative here, what I'd recommend doing is writing it as a, here's how I'm going to do it. It's -15r, but I'm going to put a plus sign here. And I'm going to do -15r. just so that it doesn't look like we're multiplying. Imagine if that's not there, it looks like we're multiplying. So again, I've got the recording on factor by grouping. And now let's see what we can factor GCF from each of these. These both have an R and they're both divisible by 2. So we can take out a 2R. 6 divided by 2 is 3. And if we take an R, we're going to be left with an R. Negative 4 divided by 2 is negative 2. Again, the R is gone, so it's just a 2. Over here, since we have a negative 15, we're going to want to take that negative out. But what are they both divisible by? They're both divisible by 5. So again, imagine yourself dividing by negative 5, dividing by negative 5. So if we take a negative 5 out, that's going to leave us a 3R and a minus 2, which is great because that matches. This here matches with this. Okay, so we can take that factor out. 3R minus 2. And then write everything that's left over. All right, so this guy's gone, this guy's gone. They've both been factored out up to here. So that's going to leave us the 2R minus 5. Again, just to keep things not looking messy, 2R minus 5. And again, you can FOIL that up, or you can do the box method just to make sure that it does work, that when you multiply this, it should give you back that product. But just mentally, I'm checking it, and it looks good. So that is factoring using the AC method, used whenever your lead term is not a 1. If it is a 1, then I'd recommend, again, just making the shopping list of what 2 things you need to multiply to give you C, but add to give you B. Those are usually pretty quick. But I'm going to stop right there. I'll do factoring by differences of squares in a different